Hi everyone, good morning, good afternoon, and good evening. Just a bit about me. I'm Kaushik with more than 17 years of industry experience, and for last decade, I'm working on microservices and on cloud architecture. Recently, for last couple of years, I'm working on AI and ML as well. Let's get started. Today, I'll be discussing how multi-agent model can significantly enhance prompt engineering to improve user interactions and response accuracy in AI-driven system. Let me start by giving you an overview of what we will cover today. First, I'll provide an introduction to prompt engineering, covering some basics as we have audience from diverse background. Then we will look at multi-agent model and how they work together. Next, we will explore examples and implementation strategies. Prompt engineering is essentially the art of designing and refining inputs prompt to elicit user response from an AI model. It is crucial because the better we design our prompts, the more accurate and relevant the responses we receive. Therefore, first we need to craft the prompts like providing context, examples, and other information. In this, choosing the right words and phrases plays a key role as processing is going to be based out of this input. There should be a clear balance so the model will be consistent and it won't overfit or underfit. The key step is to break complex tasks into simpler subtasks without overloading the model. If we look into the current challenges we encounter are vague inputs which are too broad and it is ambiguous. So when a user enters a prompt and a question and if it is too generic, then it's going to be challenging. The prompt creator has to take language and cultural aspects into account. Especially in current globalization, prompts have to factor the cultural difference and the sentiment of the users. The last and foremost is to ensure the confidential data and sensitive informations are handled in accordance with compliance and ethics. In terms of prompt engineering, the engineers may end up in creating various types of prompt like open-ended, close-ended, etc., which will still address only specific areas. And if the user has a wider variety of targeted audience, and if we need to come up with more prompts, then the prompt engineer have to factor everything in, and the complexity of the system is going to multifold. And still, above challenges have to be factored and they stay valid. Now, let's talk about multi-agent model. These are systems where independent agents collaborate to perform a task. Each agent is specialized to handle a specific aspects of the task, much like team members each having their own roles in a project. These agents work together to clarify user inputs, refine it, and generate a response and validate that response. This creates a continuous feedback loop that allows for future improvements, especially if you are hosting and training a model. In the context of prompt engineering, each agent plays a distinct role. The clarification agent asks follow-up questions to gather more details about vague or incomplete input. Let's say if user enters hi, it doesn't mean anything. So the clarification agent understands the scope of the application or the targeted user and should construct a follow-up questions to get more clarity. Before calling the clarification agents, we can make use of RAG to get some data if needed about the user and pass it on to the AI agent. Say, for example, we will be going over a medical chatbot in some time. So, if we are having a user database and a known history of medical conditions, definitely that is going to make the clarification agent much easier and straightforward. The refinement agent structures the input in a way that's easier for the AI to work with. This creates the prompt as per the specification of the response agent. In this scenario, when we say the response agent, it could be different AI models or the agents, and we could, based on the models, we can frame the prompts such that the refinement agent can satisfy the needs of the agent. The response agent is the actual one which generates an appropriate answer based on the structured input. The validation agent checks whether the output meets the user needs and if not trigger another round of clarifications. Lastly, the learning agent improves future interactions by learning from past queries and their resolutions. This is just like the thumbs up and whether we like the answer or not in the chat GPT. So which will go as a feedback to the learning agent and will refine the AI model further. Now, let's take an example and on how this works in real world. Imagine user is saying my AWS deployment is failing. This is a very vague as there are no details on which service is failing or any specific errors, etc. The clarification agent could ask more details like which AWS service are you using, like EC2, Lambda, or another. Here, the other advantages the agent, as long as it's built based on the refined data, it can provide options to user instead of again going with a simple answer which AWS servers are you using. So here we are giving a more options, which will tune the response further clear and from the user. The refinement agent then translate this into more structured prompt, such as EC2 instance with CloudFormation, assuming here the user mentioned, EC2 deployment is failed. Based on that refined input, the response agent would suggest troubleshooting steps such as checking instance type and region availability. Finally, the validation agents ask the user, did this solve your issue, and if necessary, continue the troubleshooting process. The learning agent then logs these specific issues for further interactions. So, how do multi-agent model actually enhance prompt engineering? They help by breaking down complex queries into a manageable task. The clarification and refinement agent ensures that even vague or ambiguous prompt are processed accurately. This leads to iterative refinement. Each agent improves the prompt incrementally, resulting in more accurate and relevant response. This will go in loop until the clarification is received from the user, and restricting the number of loops or follow-up questions is a good practice as there can always be hundreds of follow-up questions which defeat the purpose of having a multi-agent based prompt engineering. Over time, with the use of learning agent, these systems get better at anticipating user needs and reduce the need for clarification agent in future. Assume if we are passing user information along with the RAG inputs based on previous chat histories and user behavior, and if you are hosting an LLM model, using this to train the data will make the AI agent better to know what to expect from the user. There are several benefits of using multi-agent models in prompt engineering. First, accuracy improves because vague inputs are clarified and refined, and we will be going in loop until the inputs are clear. Second, task executions become more efficient as agent collaborates to handle complex queries, as we don't have to define what the agent is supposed to ask, which will be decided on the fly. Lastly, personalization increases as this learning agent adapts to individual user preferences over time, making future interactions smoother. And mainly, the prompt engineering has to work on creating prompts for the model, which will be relatively easier and generic than writing for the user and business. So we just need to define the prompts based on the models, whatever we are creating, and making it generic as what it is supposed to do. Then getting into the business line and enforcing what it has to do. Now, how do we implement this in a real world scenario? The first step is to clearly define the role of each agent, like clarification agent, refinement agent, response agent, etc. Then define the task and tool the agent has to use and the governing process for the agent interaction. So by governing process, when the clarification agent should stop asking the follow-up questions and calling the refinement agent, which constructs the prompt for the response agent. And same way, if we want the AI agents to use any specific tools or the um, models which needs to be done, this can also be defined. I'll give a simple demo where we have a medical chatbot and users can talk about symptoms or disease vaguely. And it is challenging for prompt engineers to create entire suite of prompts if it is open-ended and they still there is a chance for vague inputs from user. Here we have defined um, a simple rack just for a demo purpose where we have three patients, and as we could see, all the three have one thing in common, which is headache. Here the first patient have an history of migraine, and second one is tension headache, and third one with high blood pressure and occasional headaches. So when we go back to the chat, here as soon as I enter hi, the system thinks what is it age and all the set of questions which we have defined in the prompt engineering, and based on drag it is assuming the patient is known or it might be one among the three and suggesting such as headaches or high blood pressure. Here defining the prompt for the agent. Here I'm combining the clarification and refinement agent together so that the follow-up question and the prompt will be constructed by single agent. Here we are giving the information like what is the user query, the chat history, and the RAG results. Then information gathering, like what are the details we need to gather, like age, gender, race, ethnicity, and bunch of things like frequency, symptoms, severity, and their lifestyle details. And combining these informations into single and concise follow-up questions so that we are not going with each and everything, every question in iterations, and then prioritizing the most critical missing information. The follow-up questions. We can ask only one follow-up question each time and covering multiple aspects of the missing information. And if a follow-up is needed, we need to define the final prompt has not been done because in this case, the clarification and refinement agent is set together. So obviously it cannot create a final prompt. And RAG utilization, if information is available from RAG, use it. If not, go by agent's general medical knowledge. And prompt optimization. We need to have a clear and concise prompt and then avoiding repeating questions or the information is already available. And last, do not make assumptions because this is a medical chatbot. And what should be our output format? Like the thought process, follow-up questions, and final one. And then we have few reminders to limit the restrictions to three follow-up questions, which will also be hard enforced in the code, where we are limiting to only the three, after which we won't be having the follow-up questions. Now, if you look into that example, as soon as I enter hi, it comes up with the follow-up questions based on a prompt like asking age, gender, medical history, and based on drag, it's just trying to see assess if it is a headache or high blood pressure. Here, we are giving the input a different age, gender, and having no known medical history or allergies compared to what it is in RAG, and we are giving it as a severe stomachache from today morning. Now, the prompt engineering comes from the AI agent, which eventually changes the severity, frequency, and the duration of your stomachache today. And this eventually tunes further the questions specific to the symptoms we have raised. And as you could see, further down the line, it's even we are limited to only three, and it can tell what are the changes in daily routines, any stress level, travel incidents, or any known medicational conditions, supplements that has been currently taking. So it comes up with a prompt dynamically on the flow based on what user has given the input. And after this, we could see here we are printing the three iterations which is are enforced, and it creates a final prompt where it mentions the patient is like a 35-year-old male who has eaten outside while traveling. He reports severe stomachache starting from morning today with no appetite but no nausea or bowel movement changes. He denies any family history of medical conditions and is not taking any medications or supplements. So this is the prompt refined and which will be going to the response agent. That's what we have captured here. And now the response agent will provide an output based on this prompt, which will be rendered back to the user. So if we need, we can include additional user informations or whatever details in the RAG, which will be more enriched and will optimize the prompt and the follow-up clarification questions. What we have seen is a simple example, but in real world situation, it's going to be relatively complex because we need to assign roles, task, tools, and agent interaction is relatively complex. There are frameworks to support this model, making implementation easier. So what we are looking into is one of the such model, True AI. True AI provides the framework where the process will define agent a role and what that agent is supposed to do. And it also assigns a task and interactions with other agents. So agent can perform a task or delegate a task to the other agent or ask questions. Whereas task can override agent tool with any specific tools or any specific agent to handle them based on the role assigned. For example, if we have a sensitive data like a PIA information and hosting a local agent which could handle all the sensitive informations and abstract those details before it passing it to the subsequent agent. Now, in terms of solution, which one to go for? It should we go for a custom implementation or use True AI or any other solutions? Then the answer actually depends on the use case we are going to deal with. There are prompt engineers who might have created prompts specific to an application. If the scope of the application is precise and concise to only certain criteria, then we don't have to complicate the system with multi-agent model and we could stick to it. If we need a multi-agent model and if the scope is little wider but not so complex, then we may not need a very complex framework in place taking the overhaul of managing the framework. In addition, we can simply go with a two or three agent models and go in sequence based on the requirements of the application. In some situations, scenarios, a simple prompt engineering and filtration at an application level is good enough. So we are just keeping the architecture simple and not forcefully fitting multi-agent model into the architecture. This not only will reduce the cost, energy consumption, as we know AI tend to take more energies, the AI agent which is running the model, and in addition to it, we are also keeping the architecture simple and turnaround time it will be relatively quicker. So to recap, we went over what is a multi-agent model and how they play a crucial role in transforming vague or incomplete user input to a well-structured prompts. Each agent will have a specific role in enhancing or enriching the prompt engineering through clarification, refinement, and validations. And we have seen a couple of examples and how they may include improve the accuracy and coming up with the prompts specific to the symptoms raised by the user in converting a vague inputs and creating a clear prompts for the response agent to clarify. Now, I'll take a pass for Q&A, and if there aren't any questions, then Thank you very much. Have a great day. Bye, everyone.